I welcome you all to the session of engine system and performance, and today we shall discuss about the functional layout of ECU, that is electronic control unit. This unit, precisely the control unit, also known as engine management system. We have studied about this particular unit in greater details, and we had seen that this control unit houses sensors, actuators, most importantly microprocessor, that is the central part of this unit. Then for the precise operation of sensors, there are transistors, many other diodes and many other semiconductor devices. This unit houses all these electronic gadgets, electrical components, essentially for its smooth functioning as well as to provide best control to the engine. We have also studied about two different types of control. Now, we all have seen that digital technology furnishes an extensive array of options for the automotive electronic system. As such, this digital technology furnishes several options for both the closed loop and open loop control systems that we have discussed in one of the previous classes for the automotive control system. So, we know that electronic control unit, this unit essentially receives signals from the sensors, and receiving signals from the sensor or sensors, this particular unit processes data and generate control signals or output signals for the controllers, for the actuators to be precise. So, this unit is responsible for processing the data, and then upon processing the data, this unit is also able to generate control signal for the actuators. So, let us briefly recapitulate the open loop and closed loop control system, the block diagram, and then we shall discuss about the functional layout of this particular unit, that is ECU. So, if we try to redraw open loop control system or unit, then we know that we have inputs, this is controller, essentially electronic control unit, then these controllers, this controller or these controllers provide outputs to the plant. Plant is basically the system that is being controlled, and then we have some output from the plant. So, this is the layout of the I should say this is system output. If it is a closed loop control system, we have studied that there will be a feedback loop. So, we will be having controller or controllers, then these are the inputs, these are the inputs, and then again controllers or controller will provide output or data to the plant for the desired output but there will be a feedback loop. This feedback loop is given or these are the sensors and essentially this is plus minus something. So, that means you can see that this these are the measured output that we have discussed. So, essentially this feedback loop is there and this loop allows for changing that this particular loop allows to adjust for changing conditions. I should say if the system output is getting affected or if the because of some environmental conditions operating conditions. So, this should be sensed by the sensors or a few sensors and then output from these sensors will be accordingly adjusted to give desired input to the controller so as to correct that as a changed condition. So, that is the need of this feedback loop and this is very popular. So, what you can see this is also ECU, electronic control unit. So, today we shall discuss about the components of ECU and their functionalities. As I said you that electronic control unit or engine management system or ECU will receive signal from the sensors and receiving signals ECU will be able to process the data and then generate control signals for the actuators, because essentially actuator will be responsible to do some corrections, to bring some corrections so as to supply required quantity of required input so that engine can run always with its optimum condition. So, I will write a few lines about this as I have discussed by this time sensors, diodes, transistors, all these and also other electrical components, these controllers, sensors, all these components are installed in this control unit, that is ECU, and which is also known as hardware, and these are installed in a housing of plastic or metal, right. So, if I write a few lines about this, as I told you that this ECU essentially receives signals from the sensors, right. So, then processes data. We shall be discussing soon that these signals can be analog signal, can be digital signal. So, the signal that will be received by the ECU can be an analog signal, can be a digital signal. But what I am going to discuss now, the ECU is again capable of processing data, right, to generate control signals or signal for the actuators. for the actuators. Now, this processes is done by an important component, that is microprocessor. So, if I write this this process or this program or process is executed by the microprocessor or by a microprocessor, okay. And this microprocessor, so essentially there will be some inbuilt program, and that program is stored in the memory of ECU, okay. So, what we can see, ECU will receive signals from the sensors. Receiving signals, ECU is capable of processing data to generate control signal for the actuators, that is to provide some measured output that we can see from the previous, that we could see from our previous block diagram of the closed loop control system. And to generate control signal, again that means the ECU would be able to process or program, and that is executed by the microprocessor, and that program, that software program is stored or built in the memory of the ECU, okay. So, if I write here the software program is stored in the memory of ECU, okay. So, if we go to the next slide, that as I told you that ECU and other components, right. So, ECU is capable of receiving signal, will process the data, will generate output signal or control signal, and to generate control signal and process data, again there will be so many other electronic components or electrical components. So, ECU houses many electronic gadgets and electrical components, and that is known as hardware. So, if I write here that the ECU and its components are known as hardware, okay. So, in the memory of ECU a software program is installed, and all the components which are there in the house of plastic or metal, and that is known as hardware, okay. Now, what we can see, that this ECU is essentially will connect sensors, will connect actuators. So, sensors, actuators, and then power supply, right. All these things are very important. So, sensor, actuators and power supply, these are connected to the ECU, and this is done. So, if I write here, so sensors, controllers, so I should write actuators, power supply, are connected to the ECU, and this is means this connection or connections are done by, so by multi-pin plug, Okay. So, this is what we can see. Now, question is actuators. So, till now we have discussed that ECU will house sensors, actuators and many other components, and you know that for the operation of actuators we need to have high power density device to actuate, to operate actuators, and these high power density devices will generate some heat. So, these high power density devices which are responsible for the operation of actuators are also integrated with this ECU, so as to have better heat transfer. So, ECU will also house or will also accommodate high power density electrical device which are used to operate actuators, so as to have better heat transfer. So, if I write here briefly, ECU will accommodate high power density circuits. So, ECU will accommodate high power density circuits, right, that provide direct control to the actuators. And as I said you, this high power density device will generate excessive amount of heat, and that is why these high power density circuits are provided inside the ECU, so as to have better heat transfer. Okay. So, the question is, a question may arise, why do ECU is required to accommodate high power density circuits, right? Why do we need to accommodate high power density circuits in the ECU? So, the reason is these high power density circuits are responsible for the actuators, rather these circuits provide direct control to the actuators, and since these circuits will generate heat, that is why they are built inside the ECU, so as to have better heat transfer. Okay. Now, if we go to briefly discuss about the signals. So, ECU will receive signal and it will also generate signal. So, input to the ECU is signal, or inputs are the signal, outputs are also signal. So, let us discuss about the this part. Though we have discussed in the context of several unit in one of our previous class, or we have discussed all these things in our previous classes. So, what we write that, and most of the electronic or electrical components are surface mounted devices. So, most of the electronic components are these surface mounted devices or surface mounted components. So, if I write that control signals from the ECU to the actuators, right, control signals from the ECU to the actuators. That means, these are the signals or output signals from the ECU, right. So, this let me write here, the sensors join the actuators as the peripheral component, peripheral components linking the vehicle and this ECU, central processing unit of ECU. So, the sensors control signals from the ECU to the actuators. So, basically you know that we know, say for example, if we need to control the mass flow rate to be introduced inside the engine cylinder during intake stroke, if we need to supply adequate or more amount of mass of air, then that information ECU will receive from the sensor which is placed in the intake manifold, and then receiving this signal, ECU will process the data and then ECU will give some feedback or some signal to the actuators to supply adequate amount. So, to open the throttle valve. So, we need to have more throttle opening area, and then these sensors we need output, and the sensors join the actuators as the peripheral components linking the vehicle and the ECU. So, that means ECU will give some signal to the sensor to have more opening of the throttle valve, and that sensor joining the actuator. So, essentially actuator will give some actuator will open, right. So, it will actuate the throttle. So, this actuator will receive signal from the ECU that throttle position should be wide open, and that signal should be conveyed to the actuators by the sensors, and that is why the sensor joins the actuator as the peripheral component linking the vehicle and the ECU, because you know that the actuator will be in the vehicle itself. So, then this vehicle and ECU will provide that signal. So, these sensors join the actuators as the peripheral component. If I go to the input signals, so signals to the ECU, input signal, right. So, we had seen that signal received by the ECU are the electrical signal, right, and these signals are either analog, in most of the cases signals are analog data or analog type, but we can have digital signals as well. So, the electrical signal these are input signal, input to the ECU, travel electrical signals travel through the wiring harness and plug to reach the control unit. So, electrical signals which are the input signals to the ECU, all these signals travel through the wiring harness and then plug to reach the control unit, that is ECU. Okay. So, this is fine. As I told you that these input signals can be analog signals, input signals can be digital signals as well. So, let us briefly discuss about these two. and then we will move to the another important component. So, input signals can be either analog in most of the cases or digital signals, right. If the signals or signal is analog, then so can have this particular signal can have any voltage level within a specific range, right, and quite important to know is the physical quantities, those are monitored as the analog signals are. So, if I write here physical quantities, physical quantities monitors as analog data are induction of air mass, then battery voltage, and or the voltage and or there are many, but I should write at least the three different types: induction of air mass, battery voltage, and intake manifold pressure. Right. Now, question is that microprocessor. So, the digital circuit we have talked about in our previous classes can read only two different digital states. So, if the physical quantity which is monitored as analog data, so analog signal must be converted to digital before processing, right. So, this analog to digital converter is there, this converter converts analog data to the digital one. Okay. So, let me just write the although I have written, but I can write here. So, analog to digital converter ADC converts to digital analog data to digital data in the microcontroller. So, this is done inside the microcontroller. Okay. Now, if we write digital signals, as I told you that any digital signals or digital signal has two different states. Each state is identified by a particular level of voltage, typically or current voltage, 0 volt, and another one is 5 stroke or 3.3 volt. So, now digital signals have two conditions, two states like this. Okay. One is high level or high state, logical 1, and number 2 is low level or low state, logical 0. Okay. And physical quantities monitor as digital data, digital signal are rotational speed, right, and magneto. So, rotational speed pulses I should write. So, rotational speed. So, this rotational speed can be measured using Hall effect and magnetoresistive sensors. So, that so I should write here this is. So, if it is a digital signal, input is a digital signal, there is no need of analog to digital converter. Okay. Since this is digital signal, microprocessor can process this data without any need of prior conversion. So, next that ECU, just I will write this information. ECU, electronic control unit, has other circuits as well. What are those? One is known as special circuit, one is special circuit, number 2 is protective circuits. So, these two different circuits are also housed in or within the ECU. So, basically we are trying to discuss about ECU layout. So, these two circuits are also built inside the ECU. So, why do we need to have the special circuit and protective circuit? Let us discuss briefly. You know that when the input signal is pulse shaped, so I will write here a special circuit. Right. So, this circuit transmit. So, when input signal is pulse shaped, right, then the special circuit, then this special circuit, the special circuit are there to conditioned. So, special circuit are used to suppress the interference pulses, while actual pulses, certainly signal pulses, are converted to digital square shaped signal. So, that means if there are pulse shaped signals, then there will be a few interference interference pulses. So, if we allow the interference pulses to go into the ECU, then ECU will not be able to function properly, it will start malfunctioning, and then if ECU is unable to function properly, output from ECU will be again not correct. So, essentially the objective of having ECU will not be there, I mean will not be justified. So, the special circuits are provided so as to suppress the interference pulses on and only to allow the actual pulses, and also the actual pulses will be converted to digital square wave signals. What about protective circuits? So, if we write protective circuits, number 2, the protective circuit, these are used to limit the voltage of incoming signals. So, these are used to limit the voltage of incoming signal to a level suitable for conditioning. Right, and while the name itself is protective circuit, so objective is to only allow or limit the voltage of the incoming signals suitable for conditioning, that means superimposed signals will be removed. So, these are the special circuit, and finally, the most important component is the microprocessor. Of the ECU. So, you know that the most important digital integrated circuit, to evolve has been the microprocessor, right. So, this is very important component, size is very small, but has the capability of holding 2,50,000 gates in a 1/4 square inch area. So, that is very important, and we shall be discussing about a few important points of this particular, because we have discussed about many components, and in the beginning of today's class we said that ECU houses many electronic components, electrical components, and all these components are installed in a house of plastic or metal, and ECU along with all these components is known as hardware. So, let us briefly write a few points about this very important components of the ECU. Okay. So, microprocessor unit, that is also known as MPU. So, unit MPU has broad applications in automotive electronic system, that we know. So, this is the central component of the control unit. It has broad applications and controls it operative sequence. So, control unit and controls the operative sequence of ECU. Okay. And so, now again this microprocessor also, as I told you, is an important IC, integrated circuit, that can houses 2,50,000 gates in 1/4 inch square area. So, you can imagine the ability or capability of this particular IC. So, MPU or microprocessor unit incorporates a relatively complicated combination of digital circuits including ALU, registers, decoding logic, etc. Right. And this MPU microprocessor unit, apart from CPU, apart from the CPU central processing unit, contains not only input and output channels, but also timer units, random access memory, read only memory, RAM, ROM, and peripheral assemblies. Right. Most importantly, all these are integrated on a single chip. So, that is the single, I should write microchip. Okay. And that output from the microprocessor unit will be the output signals, and two different types of output signals are there from the MPU. Just I will write the names here. So, two types of output signals, two types of output signals are considered. Right. Microprocessor unit, which are so basically microprocessor unit or MPU will give some signals to the actuators. So, that means MPU triggers the drive of the controller to actuate actuators, and typically two different types of signals are considered. That is what I have written over here, and let me write these two types are one is switching signal, first type, that is switching signal which switches the actuator on and off. So, actuator will actuate based on the signals or based on the input signals, those will come from the microprocessor unit or MPU. So, first type is switching signal, that means it will switch on and off the actuator. Second type is known as pulse width modulated. Pulse width modulated or PWM, pulse width modulated. So, this signal, this pulse width modulated signals are used to actuate or to control wide varieties of actuators, right. So, to summarize our today's discussion, we have discussed about the electronic control unit and its subcomponents. That means, electronic control unit or control unit houses several components, those are electronic components, electrical components, so as to run the engine always at its optimum condition. Not only that, control unit has to function always efficiently, and to have always best efficiency of the control unit, this particular unit houses many electronic components like transistor, sensors, diodes and many other semiconductor devices, many electrical components also, and these are how these are connected to ECU and what are the output from ECU, and to have some output from ECU, again we need some devices or system, and we have discussed all these things in today's class. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.